All right, so today we are moving on to multiplying these polynomials. We'll spend about 3 days on this concept. So we have to go back to what we were learning last week with our exponents rule and review what product rule means. So when you multiply powers, you add the exponents. And we will be multiplying powers today within our polynomials. So it is easy to confuse the properties for adding monomials with properties for multiplying monomials. So let's review them here. So we were talking the last couple of days that when I have two polynomials that I'm trying to add, I'm grouping like terms together where I have 1 plus 1 would equal 2x cubed. Okay, so that's when you have addition in the middle. When you have multiplication in the middle, that's where you're adding your exponents. And they don't have to be the same because you're multiplying instead of adding. So here, when I have x cubed times x cubed, this is x to the 6th power. Okay, so that's the difference. If you have addition in the middle, you're just adding the coefficients. If you have multiplication in the middle, you add the exponents. All right, so we will need both of those things when we're doing operations with our polynomials. So here let's talk about a monomial times a monomial, which is just one term times one term. So this would be the most simple version here. So I am going to multiply my coefficients like normal and add our exponents. In fact, we've already done quite a few of these in our notes from last week. So 3 times 6 is 18. 3 plus 2 would give us 5. Okay, so this is our answer here. 2 times 5 would give us 10. This n squared is the only one, so I'm just going to rewrite it. Remember, like terms do matter. So in terms of multiplication, they have to be the same variable. So I just have the 1n squared. And then here I have m to the first times m to the third is 4 total m's. Right, and then last one here, 1/3 times 12 would give me 4. X squared times x cubed would give me 5 total. Y times y to the 4th would give me 5 total. And z squared times z to the 5th would give me 7 total. So that would be my answer here. So essentially, since these are just one term times one term, we've just done the product rule, which we learned about or reviewed last week. Now we'll get into some longer polynomials here. Here's a monomial times a polynomial. So here I have a monomial in front and I have a binomial in my parentheses, 2 terms. And on this one I have a monomial in the front and a trinomial, 3 terms for my second one there. So really what's going to happen here is we're going to distribute. So 2x squared y times 3x would be 2 times 3 is 6. I gain an x to have 3 now, and then I still just have the 1y. And then we will do it again for this negative y. So negative 1 times 2 is a negative 2. I only have the one set of x's, so I'm going to rewrite x squared. And then y times y is y squared. Okay, so this would be our answer for this problem. Another way you can organize your thoughts is by using what we call the box method over here. So I'm going to put my 4b to the 4th on the left side since that's my one term. And then I'm going to put each of my terms along the top here. And this might help you see exactly what you're multiplying. So negative 4 times 3 is negative 12. B to the 4th times b squared is b to the 6th. Negative 4 times 7 is negative 28. B to the 4th times b is b to the 5th. And then negative 4 times negative 5 is 20. B to the 4th, because we just have that one set of b's. Right? And now when I rewrite this, I'm just going to put them next to each other again. And then that positive 20 means we're going to put a plus there. Plus 20b to the 4th. Okay, so you can do it either way. Usually this helps, especially when we get into larger things we're multiplying. Okay, so binomial times binomial. This is the most common that we will be using throughout this unit, where it's 2 terms times 2 terms. And the box method will most commonly look like this, where you have a 2 by 2. But first, let's just talk about what this would mean. So x plus 5 squared is x plus 5 times x plus 5. And if you're going to multiply a binomial times a binomial with the distribution method, you're going to have to do what we call double distribution, where you are multiplying the x times both terms, and then you go back and you multiply the 5 times both terms. So let's do this blue part first. X times x is x squared. X times 5 is 5x. And now we'll do the green. 5 times x is 5x. 5 times 5 is 25. Now you have to remember to combine like terms. We are not fully simplified because I still have two x's here. I have 5x plus 5x would give me 10x. And now we are finished on this one. This next problem I'm going to go ahead and do with the box method with you. So we have 3x squared and minus 5 for one term. Then we have 2x and 7 for the other, and it doesn't matter which side you put them on. I could have flip-flopped these if I wanted. So 3x squared times 2x is 6x to the third. 3x squared times 7 is 21x squared. Then I have negative 10x and negative 35. And then since none of these are like terms, none of them have the same variable with the same exponent. All the exponents are different. There's nothing to combine on this one. So I'm just going to rewrite them in order next to each other. So this is the polynomial I get once they're multiplied out. All right, one more slide. Okay, so multiplying, this time we have a binomial times a trinomial. Again, I'm going to have to double distribute. I'm going to distribute that x to all three. And then I'm going to have to distribute this 3 to all three. And you can either do what we call double distribution, or you can use the box method, whichever makes more sense to you. So I'm showing you both. So here, x times 2x squared is 2x cubed. X times x is x squared. And whenever you have a positive, make sure you do a plus. X times negative 2 is negative 2x. And now I'll have to go through and do all of my green arrows here. 3 times 2x squared is 6x squared. 3 times x is 3x. And 3 times negative 2 is negative 6. Now I have to go through and combine my like terms. So I have a couple of x squareds here I can combine, and a couple of x's to combine. So I still have that 2x cubed in the front. 1x squared plus 6x squared is 7x squared. When we're combining like terms with addition and subtraction, we just add the coefficients. 1 plus 6 is 7. Negative 2x plus 3x is 1x. And you can put the 1. I tend to leave it off because it's cleaner, but you can. And then I saw that minus 6 on the end. So this would be our final answer. What is nice about the box method is when we have like terms to combine, they often are arranged where they're in the diagonal. So let's go ahead and do the box method on this one so I can show you that. So I'm going to put my 2x and my negative 3 on the left since that's my 2 term spot. And then I'll put my other 3 on the top. So here, 2x times x squared is 2x cubed. 2x times 5x is 10x squared. 2x times negative 10 is negative 20x. Then here I would have negative 3x squared. Negative 3 times 5x is negative 15x. Negative 3 times negative 10 is a positive 30. And what I mean by the box method organizes it for us nicely is my x squareds are across right here, and my x's are across right here. So the things I need to combine, I can see on the diagonal, where here they were more out of order. Okay, so I still have my 2x cubed in the very front. Then I have negative 3 plus 10 would give me positive 7x squared. Negative 15 plus negative 20 is negative 35x. And then I still have that plus 30 on the end. All right, so that's it for today's notes. You do have a short delta math assignment to work on at this point.